We're going to zoom in down to the cellular level to understand exactly what insulin is doing that makes it hard to lose fat. And it has a whole lot to do with the mitochondria. This is your 2-minute biology on insulin resistance and what it's doing deep inside of the cell to make fat loss hard for you. Save this post. You guys have probably heard of the mitochondria. They call it the powerhouse of the cell, but this is the place where your fat oxidation happens, where your fat is actually burned. Muscle cells, they tend to have a lot of these because they need a lot of energy because they do all the movement. Fatty acids enter the muscle cell as triglycerides, and these travel in the cytoplasm of the cell until they reach the mitochondria. I should have put a trigger warning. There's a little bit of cell bio on this. The cytoplasm is the jelly-like fluid that everything inside of the cell floats in. Fatty acids travel through this cytoplasm until they find one of the mitochondria that's floating inside of the cell. Okay, there's an enzyme called carnitine palmitoyltransferase 1 and 2 that allows that fatty acid to get inside the mitochondria to be used and burned. This is kind of like a gatekeeper for fat to get inside the mitochondria, and when insulin is up, this doesn't work as well. Insulin resistance prevents all of that energy from being inside of the cell and causing problems. Energy that isn't used causes problems. It causes reactive oxygen species that can degrade proteins and degrade your DNA. Degrading DNA is bad because that can cause stuff like aging. We don't want any of that. So if there's too much energy in the form of all that blood sugar, or if too much fat is getting into the cell, insulin resistance protects the cell. And a side effect of this protection is that you can't burn fat as well, but you want this in order to protect the cell, okay? So this is the reason why we have all this fat that accumulates if you are insulin resistant. It makes it more likely if you are insulin resistant, okay? It is a side effect of something that was originally trying to protect you. How do you get rid of it? You've got to use more energy. So using that energy is what is going to help you, but also taking in less energy so that you're not overloading the mitochondria with energy that you're not even going to use. And so since your muscle have a lot of mitochondria, it's going to be helpful if you use it more so that your muscle will find a reason to make more of them so that it becomes easier for you to handle fat when you have a lot of it, okay? So you do your cardio so that you can use fat when your insulin is low, do it at zone 2, and then also start lifting so that you can use the actual things that have a lot of mitochondria so your body gets better at using it. Once you drop that fat and you have that muscle, you have a body that has more fat burning machinery. This is what's going to make the fat loss long lasting. This is what's going to give you the sustainability because you have the muscle and you have the activity. You've created the precedent. I hope this makes sense. When you think of it like this, it just kind of makes sense. Go ahead and search this on Google. This is what happens inside of the cell. Let me know in the comments if you have any other questions, if I need to explain anything in more detail. If you guys are ready to start making this sustainable